say, I told the other class all 12 and then I changed my mind. I thought that was too mean. So just 6 of them by the next time I see you, okay? Now, you will find a reference for this in your textbook. There's a PDF of your textbook on your Schoology page, and we're looking at page 106 through 108, okay? So I think I still have that pulled up from last class. Under materials, there's a tab called Pre-Cal textbook. I guess I probably should double check that it's in your guys' class. Because if not, I'm right here. Materials. Oh yeah, Pre-Cal textbook right there. Perfect. We're going to page 106 through 108, and those are the pictures of those graphs, okay? What we're doing is we're trying to describe as much as we know on the graph, and that will be what we will kind of use for the rest of this unit. We're talking about functions, and so all of the stuff we talk about today is like kind of a basis for what we're doing for the rest of this unit, okay? So if you notice, I'm in 1.3. We haven't started chapter 1 at all, but I think this is a good place to start, and then we'll go back to kind of those basic beginner things, okay? There are 12 of them here, so I see 2 of these on page 106, and then you flip over to the rest of them, okay? All I need you to know is the picture, the name, and the equation for the next time we quiz, which is either Wednesday or Thursday on Schoology. Okay. This textbook is on here just as a reference to you. I will never assign problems out of here, but if you want extra work, or if you just want to read it, or you're like, Miss White didn't do a good job, I'll do it this way. Okay. So we are going to get into the first one. So the first one's identity function. So if I go back to my textbook, it is this first function right here, which is basically a line, right? Okay, perfect. We're doing new notes, so right now. It's a line, and my equation right here is y equals x. So I'm going to go over to my part right here. It's my identity equation, and my identity function, that's the name, and its equation is y equals x. Okay, so I'm going to sketch a graph of that. It's just a line that goes through 0, 0. If your axis is not strong enough, feel free to draw another line to kind of strong up your axis so that you know exactly what's your y and x axis. It's a straight line that goes through the middle of the page. It goes through 0, 0, and it goes on and on forever. All of these we can interpret from the graph, and these are all words that we're going to use through this unit. So that's kind of why we're starting here today. But I believe you know some of these, and I believe some of them maybe are newer. So we'll just go through it one at a time. When I'm talking about domain and range, domain is which values? My what? X's, good, and then that means range my Y's, good. So I want to know what X's are here. My domain, in this case, I am using all my X's, right? So it's going to be all real numbers or negative infinity to positive infinity. Flip a couple of pages. Right there. What about my range? What about my Y's? It goes through 0, but I think it goes all of them. I think all of them are there. I have a picture, or I have a point on every single y that I see here. So negative infinity to positive infinity. All right, when I think about continuity, I ask myself, did I have to pick up my pencil? Or could I draw this without picking up my pencil? On this one, I can draw a straight line without picking up my pencil. So this is continuous. It has continuity. So yes. If I have to draw something and then pick up my pencil to draw the next part of it, that would be non-continuous. We'd say no. All right, the next part, increasing, decreasing, has to do with what's my graph doing as I go across the page. As I read from left to right, what's my graph doing, okay? So I start down here at the bottom, and as I go across the page, what's my graph doing? Increasing or decreasing? It's increasing the whole time, just a certain part, the whole time. So I'm going to say that it is increasing. I'm going to say INC for increasing, and I'm going to say from negative infinity to positive infinity. Okay. Symmetry is kind of a weird one. You have 3 options. It's either even, odd, or none. Even symmetry, when you were in like elementary school, did you ever like paint on one half of a picture and then you folded the paper over and then you did you smushed it together and then you opened it and it was like a beautiful like mirror image of what you had? That's what we call even symmetry. Odd symmetry is what this is right here. If it's the same in the first quadrant and the third quadrant, we call that odd symmetry. So this is an example of odd symmetry. We'll do more of those to kind of catch up on when it works or when it doesn't. Next, I've got boundedness. Boundedness means there's a floor that I can never go lower than, or there's a ceiling I can never go higher than. Are there any floors or ceilings in this picture? Nope, we keep going forever and forever. So I'm gonna say there's no boundedness, no. Okay, the next word is new. I think my other class seemed to not know what the word extrema was. Have you guys heard the word extrema? Okay, extrema is like your extreme points. It's your max and your min. Do I have any maxes or mins on this picture? No, so I have no extrema. And you can write no for both individually, or you can write no for just that one. Now, the difference between local and absolute, in your BFF graphs, there will be no difference. However, when I'm looking at this picture right here, or if I'm looking at, I don't know, maybe like an example like this. Do you notice how like I have a maximum right here and I have a minimum right there? Those are what we call local, because with everything around it, it is the lowest one, or with everything around it, it's the biggest one. However, it's not absolute, because absolute would be like the biggest of the entire graph. Notice that this would keep going up, so there would be points that are bigger than that point right there. And same thing, it keeps going down, so there are going to be points lower over here than that point right there. So there are no absolute maximums or minimum, no absolute extrema on this graph, but there are local ones. Do you kind of see the difference between local and extrema? On this paper, if you have any extrema, it will be both. It will be both. Because these are basic family of functions. This is like the most basic graph you'll see of all of these. All right, what about asymptotes? What do you guys remember about asymptotes from algebra 2? How do we draw them?
Oh, wait, it goes down, it's like in the middle.
It could be in the middle. It could be vertical. It could be horizontal.
Is it like symmetrical?
Not necessarily. Kind of a straight line. We draw with a dotted line. Do you guys remember drawing those dotted lines for asymptotes before? Okay, those only happen when we get really, really close to something, but we never touch it. There are only a handful of these BFF graphs that have asymptotes. This is not one of them because it just keeps going on and on and on forever. So this one has no asymptotes either. And the last thing we're going to do for every graph is end behavior. And I want your end behavior to be set up like this. We're going to say as x approaches negative infinity, y is going to approach something. And as x approaches positive infinity, y is going to approach something. This is a notation that we're going to use for end behavior. We're not going to use limit notation, which we'll talk about later. Your answer here will either be positive infinity, negative infinity, or a specific number like 0 or 5 or something like that. So let's look at my graph. As x approaches negative infinity, so like as x gets smaller and smaller, what's my graph doing? It's going down, right? It's becoming small. Y is going also smaller and smaller. So as x approaches negative infinity, so is y. Y is also approaching negative infinity. We're going to do a similar thing. We're going to look at when x gets bigger and bigger. So when I move to the right of my graph, when x is getting bigger and bigger, what's my graph doing there? It's getting bigger and bigger, so it's going to approach positive infinity. Okay, so we're going to do that. We just did one of the 6 that we're going to do total, okay? I want to do at least 2 or 3 before I kind of let you guys loose to kind of see what can you do on your own versus what do I need to talk to you with, okay? You feeling okay? Does anybody have any immediate questions? Because I bet a question might come up when we do a couple more. So let's do another one. Let's do the squaring function. Okay, if I go look at my graphs, my squaring function looks like this. Do you think of another name for that?
Parabola.
Parabola? I can think of another one too. Quadratic. I don't care if you call it squaring or quadratic or parabola, but we're going to go draw one on our graph and we're going to write the equation y equals x squared. Now, my other class wasn't as familiar. You could just draw a U-shaped graph, but if we're going to be really specific and be as like on it as possible, I can come up with some points. It always goes through 0, 0, because 0 squared is 0, right? I'm essentially doing each x squared. So now I can think of what's 1 squared. What's 1 squared? 1. So I'm gonna put a point at 1, 1. What's 2 squared? 4. So I'm gonna put a point at 2, 4. And then what's 3 squared? 9. That's the last thing I can comfortably put on this picture. Now we know it's a U, so it's gonna be the same thing on either side. So when I have all these points on the right side, I can also write them over here on the left side, just reflected over. Once this goes, it's gonna go. There's my parabola. All right, let's answer the same questions we just did with the identity, with my line, now with my parabola. What's my domain here? Negative infinity to positive infinity, that is commonly a domain. What about my range? 0, infinity. I do want to bracket with that 0. I do not want a parentheses because I have a point at 0, so I'm including that. Parenthesis or bracket 0 and then comma infinity parentheses. Is this continuous? Did you have to pick up your pencil to draw it?
Yes.
You did to make it look pretty, right? Could I have traced it all the way with one swoop? Yep, there were no holes, there were no jumps, I didn't have to pick it up. What you probably did was you did one half and then you did the other half just so it looked nice, but technically there's no reason to have picked up our pencil. So I'm gonna say it is continuous, yes. All right, the increasing and decreasing is a little different here, okay? I'm gonna go as I go across the page, so from left to right. When I start here, what am I doing with my graph?
Decreasing.
Decreasing until when? X is 0, good. So I'm gonna say that I am decreasing DEC from negative infinity to 0. Math teachers argue on this. I like a parentheses at my 0 because technically 0 is not increasing or decreasing, it's where the change happens. So I use a parentheses there. Okay. Then at 0, what happens? I increase until when? Infinity. So then I'll say INC for increase, and then I'll go 0 to positive infinity. Excellent question, Millie. That is a great question. On these, we're decreasing until we get to 0, and then we start increasing at 0, right? So I'm going to argue 0 is kind of in both of them, so then it doesn't get to be in either of them. In the range, there's an actual point right there at 0, so because it's a closed solid point, I'm going to include it with a bracket. All right, symmetry. What's my symmetry here?
Yeah.
Yes, good. This one is what we call even because it is a parabola. It's a reflection on both sides. So we're going to call it an even symmetry. Okay, and then boundedness. Does this have a floor or a ceiling that I can't cross? The floor, right? It's bounded, what we call below. There's like a line below that I can never go below that line. I have to stay above it. Below, and we'll say at x equals 0. All right, this time I do have an extreme point. I do have a max or a min. Where is it? 0, 0. And I'm going to count it as both my local and my absolute extreme. Because it is lower than all the points around it, but it is also the lowest of the entire graph.
What is absolute mean?
Absolute means of everything. Is the absolute highest point or the absolute lowest point. All right, any asymptotes here? Local mean again? Local means like nearby. Think about like local is like if we have a problem like at Cathedral, like not everybody knows about it, right? Like your aunt in California probably doesn't know about like whatever drama we have here at Cathedral. But if there's something going on like in the entire United States, like that is a problem that everybody knows about. Or like we all know about like what's going on in Ukraine, right? Like that's an absolute problem. We all know about it. But like if there was like a fight here on campus, like people like at another school maybe wouldn't know about it, or people in Ohio wouldn't know about it. Local versus absolute. Any asymptotes? No asymptotes. We'll do an asymptote example in a second. And then end behavior, let me write that one out again. So as x approaches negative infinity, we want to know what y does. And as x approaches positive infinity, we still want to know what y is doing. Okay. This time we kind of start in the middle and we go out away from it. So as x approaches negative infinity, as x gets smaller and smaller, what is happening to y? Getting bigger and bigger, it's going up. So we're gonna say positive infinity. What about as x approaches positive infinity, what is y doing? Also going up. It can be the same thing. As x approaches negative infinity, y is approaching positive infinity, and as x is approaching positive infinity, y is still approaching positive infinity. Okay. Are we feeling okay? Right. I don't want to do the cubing function with you because I think it's easy enough for you to do on your own. Let's just go look at it so we can graph it. The cubing function is x to the third, and it's just kind of like a squiggle or a snake or an S through the center, through the origin. If we want to be as exact as we were with our quadratic, we can graph this one through 0, 0, and then I can think about, okay, well, what's 1 to the third power? Well, that's still 1. And then what's 2 to the third power? 8. So it's a pretty narrow graph. And then same thing for negative. When I cube -1, it gives me -1, and when I cube -2, it gives me -8. I think I put 7. And again, I might pick up my pencil to draw this nicely, but I could connect all of those points. Oh, I did it without. Okay. Notice how narrow and skinny it is, but it still has arrows, so it still goes on and on and on forever in all the directions. It goes like, it travels the y much faster than it's going to travel the x. But we're going to get to, like, we could cube -10 or +10. It just would be like this giant number. So it just is a pretty skinny graph. Okay. And then again, that's x to the third. I'm gonna let you guys try that one on your own in a minute, but let's do one more where we can explore something together. Flip your paper over. Let's do the very next one, which is the reciprocal function. We also call this one the rational function. Okay, let's go look at what that is. This is my reciprocal or my rational function, okay? It's basically like a C curve in the first quadrant and in the third quadrant. We're getting closer and closer to the axes, but we never, ever, ever touch them, okay? And my equation is 1/x. 1/x. Let me go draw that. We will deal more with rational functions or reciprocal functions in the future, but for the most part, as long as you give me kind of a C curve in the first quadrant and a C curve in the second quadrant, then you're going to be good.
In third one,
Did I say fourth?
said 30%.
Okay, third. Yes, thank you, Chase. I'm at the point of the day. Has today just felt like the longest day of your life? I'm like, why am I still teaching? Why is it only F period? Why are we not done? Like, why has this day been so long? So I'm just getting to the point, like, I just don't, like, I was saying words. I'm like, I hope it's kind of right. What'd you say? It's so long. Whenever we have those kind of morning activity, it feels like such a long day. Okay, moving on though, this is our graph. So let's kind of go through it because this is a little weird. The first thing I want to mention is that we do have asymptotes here. I don't know if you guys remember graphing these back in algebra 2, but we do have a vertical asymptote through x equals 0. And I have a horizontal asymptote through y equals 0. I know that there's asymptotes, even though they weren't physical little dashes in our textbook. I know that there are asymptotes because we're never crossing either of those axes. We're getting really, really close, but we're never crossing them. So that means that there are asymptotes there. Okay, yeah, Millie. I'm confused on this. The reason this one has an asymptote is because it's 1/x. So if I were to do 1/0, if I were to plug 0 in for x, could I do 1/0? Remember when we do slopes and we have 0 on the bottom, we call that undefined? That means it's a straight vertical line. So if I plug 0 in for this, I will not get any answers out, which is why I have an asymptote, because I can never cross the x-axis because there should not be any point there. Not as easy an explanation for vertical, but just trust me, the vertical one's there too. Okay, so that's why it's kind of funky, and we will explore more of this in chapter 2. I just want you to have a basic idea of this picture and this graph. Okay, so let's do it. Let's do domain. What would my domain here be? Let me rephrase that. Oh, sorry, what did you say, Danae? No. Is there any x's not in my domain? 0 is not in my domain, right? Because there's that vertical asymptote. I can plug anything in here except for 0. So I'm gonna say -infinity to 0, and I'm gonna put parentheses here because there's no point at 0. And then I can go 0 to positive infinity. There's no 0 x's. It's gonna be the same thing for my y's, right? There's a horizontal asymptote at my y. There's no points on this, there's no points on this x-axis, there's no points on this y-axis. So that's gonna also be the exact same thing, -infinity to 0, 0 to infinity. Okay, was this continuous? No, I had to pick my pencil up, right? I did one curve and then there was no way for me to try and go do the second curve without picking my pencil up. So this is not continuous. All right, increasing and decreasing, this is confusing. I always have to remind myself this one, okay? Again, as I go across the page from left to right, I start here, what am I doing? Decreasing, okay? I know I'm gonna pick my pencil up, but when I start again, what am I still doing? Decreasing. It is decreasing the whole time. The whole graph is decreasing, and I know that there's no points at 0, but I'm still just gonna say decreasing from -infinity to positive infinity, just because the entire graph is decreasing. The whole graph is decreasing. Okay, this does have symmetry. Does it look more like the line, or does it look like the parabola, my U? It does look curly like the parabola, but based on the quadrants I'm in, is it more like the parabola or the line? The line, right? I'm in quadrants 1 and 3 again. This is an odd symmetry. This is another odd symmetry. Anytime you have the same thing in quadrants 1 and 3, it is odd symmetry. Now, boundedness means that there's, again, a floor that you cannot go below or a ceiling that you can't go above. I'm gonna argue there's no boundedness because there is stuff below. I don't know why I did that. There is stuff below and there is stuff above. Okay, so there is no floor or ceiling that's gonna deny you access to go to one side or the other. So there's no boundedness. What about any extrema? Are there any maxes or mins here? Nope, not one. So for both of those, we can say no. And then we already did our horizontal and vertical asymptotes. And then let's do our end behavior. As x approaches -infinity, y approaches blank. And as x approaches positive infinity, y approaches blank. Let's look at our graph. Again, this is different than increasing and decreasing. With end behavior, we start in the middle. And I say, okay, as x gets smaller and smaller, what is my graph doing? What's it getting closer and closer to? Not -infinity, not positive infinity, 0. It gets closer and closer to that axis, doesn't it? If it was going towards -infinity, it would look like this. As x gets smaller and smaller, then my graph would be going down this way, but it's not doing that. If it was approaching positive infinity, it would go above like that, but it's just getting closer and closest to the axis without crossing it. So we're going to say that it approaches 0. What about on the other side? What about when I do as x approaches positive infinity? What's my graph approaching? 0 again. I want to time out for a second. We still have about 25 minutes in class. I want you guys to kind of struggle on your own for a little bit, and then I want to help you out again, okay? We've done 3 of these. And again, at the end of the day, I want 3 more of them done by the next time I see you. I will put the graphs on the board, but you also may want your iPad out so you can look at the graphs a little bit closer. I would maybe go through, find out if there's any that you definitely want me to look at with you guys before I leave, or before you leave, so that you have those done. If not, we will answer questions the next couple of days, but I want you to kind of do 3 more, almost on your own. So I want you to kind of see what you need help on, what questions you have. Yeah, quick.
Classes that-
225?
Yeah.
Mine says 2. Oh, it does say 225. I was looking at E period. Okay, so you have 10 minutes. So maybe take like 3 minutes to see what do you need help on, so then I can maybe do 1 more with you guys. Thank you for that. Greatest integer, okay. So we vote greatest integer. Still take a couple more minutes to kind of struggle on your own. Maybe even take this time to write down all the graphs and all of the equations so that you have those as well. You have to do 6, all of them.
Okay.
Just like we just did 3 of them, you have 3 more that you need to do all the way through. I don't care. All 12 are gonna eventually get done. So, I'm sorry, did somebody say something and I ignored you? Yeah, like right here? I think you should already have 2 of those. I'll go right here.
I know it's. Yeah, but I just.
He doesn't have, thanks for the heads up.
Yeah.
1 and 2, 15, we can go, all right. Okay. That means there's a floor that everything's above it, or there's a ceiling that everything's below it.
Didn't know something in one class.
Yep, no symmetry. No symmetry is an okay option.
And then if you have like 0. Then you can divide it. That's just so.
I would say that this range though goes to the negative, right? So I would say negative infinity. What'd you say? Oh, yeah. You'll probably put those still, because they do get something. Those are no. Those are maxes or mins. Do you see any high or low points here?
No.
No. No, those are no.
That's what they.
106, 107, and 108.
There's go.
Sure. I just, you kind of paused when I was sitting here, so I waited to see if you had a question.
People say, yeah, I do. Like, I just, like these, like that.
Yeah, sometimes are all of them. Okay, so on all of these, it's no. Okay, when you start getting to, like this one right here has one actually drawn in, so that one has an asymptote. And then. Mhm. And then both of these as well, the natural log and the exponential, they both have asymptotes as well.
So do you just say yes or?
I would say at, or I would say, maybe say y equals 0.
This one,
Mhm.
it's, they started here.
It's, or does it like go, it keeps going on, but it's getting closer and closer to the axis without it.
So the main just be negative.
Yep.
The range would just be,
You know, on that one, that 0, I would not put right negative practice. I do. But lots of things.
we're not right.
I put the coordinates in here, so as long as you have 6 total, I don't care which 6 they are. Say that again. I would say it doesn't exist, right? Because you know, it doesn't, like, there are no negative infinities. All right, so if you wanted to do greatest common integer or greatest integer, so we're gonna do that one really.
Is that right?
Yeah, I would do brackets on those because there is a point of 0, 0. There are point, is that the like range of domain, what I have, you know, it's just 0. And then I do brackets. I haven't found in this because there's nothing below. So there's nothing in that y, in the negative y's. I would say it's bounded below at 0. All right, you guys are asking some really great questions, but let's do greatest integer really quick. I did that in my other class, so that's good that we kind of have a little bit of continuity with you guys.
What's greatest integer?
It is like the second to last one. And it looks like this on the board. I would like to preview this little talk is that this is a complicated one, but I also think this is just a very dumb function. Like, have you seen this before? No. Will you ever see this again? I don't think so. I have a whole degree in math. I've never ever seen that graph until I started teaching these BFFs. So if you care, I don't think this is a very important graph. So I will probably not ask you a lot about this in the future. Do you need to know what it looks like? Yes. Do you need to know that it's called greatest integer? Yes. Do you need to know its equation? Yes. Other than that, I really don't care. But let's go over, because there are a few special cases that hopefully I can help answer on this so then you don't have to worry about them later. When I draw it, you're drawing essentially a closed circle at the like point, and then we'll do an open circle next to it. So I'm going to start at 0, 0. I'm going to do a closed circle there. And then at 1, 0, I'm going to do an open circle. I'm going to connect them. Then I'm going to stair step up 1 step. I'm going to do a closed circle on 1, and then an open circle on 2. Closed circle on 2, open circle on 3. Closed circle on 3, open circle on 4. You don't need to do it much more than that. That's enough. Just do a few. And then I'll do a couple in the negative direction as well. Closed circle, open circle, closed circle, open circle, closed circle, open circle. So it looks just kind of like a stair step. Looking at this, what's my domain? All my x's are included, negative infinity to positive infinity. Now, the range is not all real numbers. It's not negative infinity to positive infinity, because you notice that we don't have anything between the like whole numbers. Basically, it's a set of integers. It's only positive and negative whole numbers. You can represent that a couple ways. You can either use this fancy z. That is the math way that we represent the set of integers. Just like remember how you know this is a set of all real numbers. The z is the set of all integers. If you don't like that, you're welcome to write it like this. We do like a brace, and then we do dot, 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 -3, -2, -1, 0, 1, 2, 3. We list essentially a handful of those numbers, and then we end with dot, dot, dot in our brace. The dot, dot, dot just means continue on in that pattern forever. Keep adding whole numbers, keep doing negative whole numbers as we go on.
And what's that other?
This is a little, the z, that's the set of all integers. So positive and negative whole number. Oh, and then the equation for this was int parentheses x. I didn't put that earlier. Okay, was that a continuous graph? When I drew it, could I have drawn it all without picking up my pencil? No way, Jose, not continuous.
No way.
What was I doing as I went across the page? Increasing, decreasing, both?
Yes.
Only increasing, right? It's going up as we go across the page. So I'm going to say increasing in positive or negative infinity to positive infinity. Now, I know this kind of looks like the line and like the cubic function and like the rational function where it looks like it could be an odd symmetry because it is in the first and the third quadrant. However, I'm gonna argue based on how the closed circles and the open circles go and the lines, it is not symmetric. So this has no symmetry. In the same way, do you think this is bounded? No, it's gonna keep going. It's gonna keep stair stepping down forever. It's gonna keep stair stepping up forever. So we're gonna say not bounded. Are there any maxes, mins, extreme points? Nope, not for either of them. So I'll just do a big no there. What about asymptotes? Any asymptotes? Nope. And then last we'll do end behavior. As x approaches negative infinity, y approaches something. And as x approaches positive infinity, y approaches something. What do you think I should fill in there? As x approaches negative infinity, what does y approach? Negative infinity. What about as x approaches positive infinity, what does y approach? Positive infinity. No, I just generally go negative and then positive. This is a boring graph because do you see how many no's we have? It's a weird one. I don't really care about it, but it was a good one to go over. So we did together 4 of them, and I think some of you even finished 1 or 2 on your own. So as long as you have 6 total of these done, then you are ready for class. Eventually, I will ask you to do all 12. Okay. I will also eventually post a key. I'm not going to leave you in the dark. I'll tell you what I think the answer should be. But remember, the next time I see you, we're going to quiz, and you need to know all their graphs, all their names, and all their equations. All 12. Not next class. It's on Wednesday or Thursday. It's on Schoology. I don't remember what day it is exactly. I can probably look though. Yours falls on Thursday, but you will need to know all those 12 things. All those 12 graphs, names, equations. Okay, let me turn